and in this video we will be discussing the population genetics concept of Hardy-Weinberg equilibrium using a fictitious population.
I'm a taco, and I talk.
As you can see, the internet provided me with wonderful content for you. A talking taco varies in the trait of spiciness. So how do we quantifiably measure the Hardy-Weinberg equilibrium, or HWE as I may sometimes refer to it? We use the equation, or law, on the screen. P squared serves as our homozygous dominant allele, 2pq as our heterozygous allele, and q squared as our homozygous recessive allele. It is important to note that these alleles are used for example purposes, the A alleles on the screen. The 5 assumptions of any population in Hardy-Weinberg equilibrium are an infinitely large population, random mating, no selection, no migration, and no mutations. Our talking tacos will begin in HWE. As you can see, genotypic and allele frequencies stay the same from one generation to the next through this graphic. As you can see here, we have a total population of 10,000. This will be the data used going forward, which includes 3 phenotypes and genotypes, as mentioned earlier. These are the questions we will answer on the next few slides and by the end of the video. Most importantly, are the talking tacos ending in Hardy-Weinberg equilibrium? We have calculated the allele and genotypic frequencies. Allele frequency of big S is 0.7 and little s is 0.3. The genotypic frequency of homozygous dominant S is 0.49, of heterozygous S is 0.42, and of homozygous recessive S is 0.09. We know that they are correct because they add to 1. We checked the random mating assumption using the Hardy-Weinberg equilibrium equation as well as the Punnett square method to be safe. The random mating check results must match the initial genotypic frequencies if the talking tacos are in fact in Hardy-Weinberg equilibrium. Although our population began in HWE, after a chi-square analysis, we notice it is no longer in HWE. We will now investigate what type of selection is causing this. We can see here that our selection is directional because the frequency is favoring big S, big S. Directional selection is typically caused by environmental factors such as climate change. The talking taco can be heavily affected by that, specifically as it thrives in warmer temperatures. My prediction is that the mild talking taco will be the majority in evolution of future generations. This is the chart I used to find post-selection data. We use fitness to calculate the remaining post-selection allele and genotypic frequencies you will see on the next slide. After directional selection, the talking taco population is no longer in Hardy-Weinberg equilibrium because the genotypic and allele frequencies clearly did not stay the same based on these calculations laid out here. When change occurs from one generation to the next, a population is violating Hardy-Weinberg equilibrium. Thanks for watching.